container. Let us first of all draw it. There is a container, a cylindrical container. There is a solid sphere of radius r, and the material from which it was drawn has a bulk modulus K. It is surrounded by liquid. Okay, there is liquid all around it. Fine. It is liquid, man. Liquids can't be shown by black. No, it will give a bad impression. Come on. I can show it by red as well. Okay? Say this is the piston here. A massless piston of the area A. So the area of this piston is A. Floats on the surface of the liquid, covering an entire cross section of the cylindrical container. When a mass M is placed on the surface of the piston to compress the liquid, okay. So if you are placing some mass here, mass M, what will happen? This will compress. So it will compress the liquid, but that compression will produce some change in the volume, of course, of the solid sphere, isn't it? The fractional decrement in the radius of the sphere is mg by alpha AB. Okay, what is B? A is the area. Okay, bulk modulus is B. It's not K. Fine? Find the value of alpha. That is the question. So obviously when you are applying some force, fine. First of all, can you tell me what is bulk modulus?
Normal stress by
Volumetric stress by volumetric strain. Volumetric stress is the stress produced by this force, isn't it? Because before this it was in equilibrium, there was already a radius r. But the moment you are placing this mass m over the top of the piston, what is going to happen is it will get compressed, right? So the force that we have is mg, isn't it? Divided by area of the piston, because that is the pressure that is being exerted. Divided by volumetric strain. So volumetric strain will be what? Delta V by, isn't it? So what I can say is volumetric strain delta V by V is equal to, yes, mg by A, not K, but B. Fine?
okay.
Where A is the area and B is what? The bulk modulus. Fine? So that is the volumetric strain. This is also called as volumetric decrement. Understand? Because volume is reduced. But he is saying the decrement in the radius. Class 11th, I taught you errors. Have I? What is the volume of this sphere actually? 4 by 3, yes, pi r cube, isn't it?
Yes.
Can you tell me if there is some change in radius or error in radius? What will be the error in volume?
3.
I told you, it is fractional change in volume, delta V by V. That will be equal. Now 4 is constant, 3 is constant, pi is constant. There will be no change. But it will be 3 times delta R by. So can I say delta R by R is equal to 1 by 3 times delta V by V?
Yes.
Can I
Yes.
use that concept here? So instead of delta V by V, I can say it is what? 3 times delta R by, and it's okay, don't use that concept. Understand the concept. Volume has 3 dimensions, isn't it? So if the fractional change in volume is this, then the fractional change in the radius 3 times would be this. Isn't it? It's quite obvious. Therefore, that is equal to what? mg by AB. So technically, we are asked to find delta R by R. That will be equal to mg by 3AB. Isn't it? So what was the question? mg by alpha AB. AB 3. So answer is? Is it clear? By the way, by what value should the temperature be increased so that the volume, so that the radius of this doesn't change? Can be a question, because up till now he was changing the applying a force on the rod and also increasing its temperature so that it didn't change. But now what if the same thing is being done here? Huh?
Yeah, equal to.
So that time what we will do? We will use gamma, right? Isn't it? By definition of gamma, what is gamma? Yes?
3.
Mm-hmm.
3.
No, it is the same. It is the fractional change in volume per degree rise in temperature. I'll keep it delta theta. Fine. So we can say delta theta times gamma is equal to fractional change in volume. But what is fractional change in volume? Mg by? Equate the two. So delta theta times gamma is equal to what? Mg divided by AB. So if someone tells you by how much degrees should we change the temperature so that the radius doesn't change, then delta T, the increase in the temperature, should be Mg by gamma times AB. This is the change in temperature. Another question derived from the same question. Why did this come to my mind? The reason was he was doing some change in the length, increasing the temperature, but he can do it here as well.